Yeah, this will be the last page of notes for this unit. So today we're going to do identities and even odd properties. Looking ahead, next week you have quiz F. It's your last quiz this unit. It's going to be over what we learned yesterday and today. What we're learning today in just a minute is going to be kind of like a different method to solving them, and you're going to get to choose which method you like better and do that on quiz F. On Wednesday, and then you will have time to do homework. By the way, you have 64 to 104 due on Wednesday. Evens only. 64 to 104 evens. I think on Tuesday we're going to have quite a bit of time in class for y'all to do that. Okay? On Thursday, and then on Wednesday we're going to review. I'm going to tell you exactly what's on your first test in here. Right? We haven't had a test. Nope, we haven't had a test in here. I'm going to tell you what's on your first test, what to expect, what's on the assessment. And I think we're going to play a gym kit. And I have prizes for winners. I have food. I gotta find the food. Oh yeah, I do have food. I don't have candy, but I have food. And then on Thursday you have your first assessment, and next Friday you have your first test in here. I have food. I have stress balls. I have crock charms. I have straw toppers. I have a couple different things. Okay. Puppet. I think I have some puppets. Yeah, I have some puppets. I won like a teacher wish list Instagram contest. So I got to clear my list last year and I still have a bunch of stuff from it. Alright, so the first identity we're going to talk about, and actually we've already learned some identities. You've learned the reciprocal identities. We didn't call them the reciprocal identities, but that's exactly what they are. These are all identities. Alright, they apply to every theta. They work, right? That's essentially what an identity is. The first identity we're going to talk about today is the Pythagorean identity. What is the Pythagorean identity? Well, what's the Pythagorean theorem? And I'm going to write it backwards, but you're correct. I'm going to write c squared equals a squared plus b squared. If you write it the other way, that's fine. Bless you. There is a reason. It actually stems from geometry to tell whether a triangle is right or not. That's why. In here, instead of doing C, A, and B, what have we been doing for our unit circle and our triangles? So r squared equals x squared plus y squared. Do you agree this applies to any circle on our graph? Right? That's at the origin. Today we're going to learn an identity that applies to the unit circle. And the unit circle, what do I know about it? It's what? It is 360 degrees, but what do you know? How is that different than any other circle? What's different about our unit circle? The radius is 1. And since the radius is 1, what do we know about x on our unit circle? What is x? Not at a certain degree. What does x represent on the unit circle? Huh? Are y'all following me now?
A little bit.
Okay. What does y represent on our unit circle?
Y.
Oh, thank God. Okay. And although it is written like that, we are not going to write it like that. The way that we are going to write it is we are going to say 1 equals, we write it like this because I don't want you to square the theta. I want you to square like the whole thing. This is called the Pythagorean identity. So, what does this even mean? Why are we doing it? Well, if I asked you to simplify the following, you can now do that. Example 1, cosine squared of 74 plus the sine squared of 74. Don't say sin. You'll hurt my ears. Don't say sin.
I didn't say sin.
Oh, what'd you say?
I said 70.
Oh, no, not 70.
No, I was talking to you.
Oh, okay. Cosine squared of 74 plus the sine squared of 74 is what? What? 1. And that's how you do that. Now, a couple things about it. They have to be the same theta. You couldn't have 74 and 82. It wouldn't be 1. The other thing is they have to be squared. If they're both not squared, this doesn't work. Okay? If you had your homework out, maybe you do, maybe you don't. Let me see if I have it out. Man, where'd it go? Oh, here it is. If you had your homework out and you looked at number 72 that is due on Wednesday, could you now do number 72?
Yes.
Bam. Like that. Okay? What questions do I have? We're okay? All right, the next identity that we have is the, I want to say tangent identities. Let me look and see real quick what they call it on your paper. Oh, quotient identities. There we go. The quotient identities. This is, well, there's a lot. Today, this is the last one we're doing. Next unit, we're going to be graphing. The unit after that is all about identities. So unit 3 and unit 4 are all identities that you will have memorized. All right, quotient identities. Quotient means to do what? Divide. So we're going to be dividing. What do we know about tangent? What do we know about the tangent of theta? It's y over x. Well, on a unit circle, what do we know about y? Oh, thank God. And what do we know about x? So what is the tangent of theta equivalent to? Sine over cosine. And that is one of our quotient identities. Because of that, what do we know about cotangent? It is cosine theta over sine theta. So how would we use this? Simplify the following. What is the sine of 15 divided by the cosine of 15 minus the tangent of 15 degrees? Why? What does that turn into?
Tan 15.
That's equivalent to tangent of 15. I'm going to bring down minus don't do that. Minus tangent of 15. And what's the tangent of 15 minus tangent of 15? 0. What questions do I have about that? Are we okay?
Yes.
Okay. So I just did with you basically examples like 72 and 74. I want to show you the reciprocal identities we've already done, how they can be used. For instance, y'all look up, I'm doing the odds on your homework. But if you look up sine of 70 times cosecant of 70, well, what do we know about cosecant of 70? It's the reciprocal of, so don't we know I can rewrite this as 1 sine of 70? Do y'all agree? Times the sine of 70, what is that going to be? 1. That's how you do the reciprocal identities. Same thing here, cosine of 50 times the secant of 50. Well, what do we know about the secant of 50? 1 over cosine of 50 times the cosine of 50, 1. Does that make sense?
Is it always going to equal 1?
No, I could totally do something like, what is the sine of 60 times the, no, I didn't mean sine. Yeah, let's do that. Times the cotangent of 60. Well, what do we know cotangent is? What did we just learn about quotient identities? What? Isn't it cosine over sine times the sine of, right? And then what happens? So what is the cosine of 60? What's the cosine of 60? So that's another way that you could do this. Now, could you just do the sine of 60 and figure out the cotangent of 60? Sure, but which way is easier? So that's where identities come in. You can make life easier like that if you don't want to do all your reciprocals. Okay? This right here is more like what we're going to be doing in Unit 3. You're sticking to these 4 for this unit. Okay? All right. Now we're done with identities. We can do a little squiggly break. Now we're going to talk about even and odd functions, or properties. If you took college algebra already, you have learned this. I don't know if y'all learned this in Algebra 2. I'm not sure. If you haven't taken college algebra already, we're going to go into even and odd functions way more in the spring. Right now, I'm just going to show you this related to trig. Okay? So I'm going to show you the very basics. A function is even. How do you know, a function is even. How do you know a function is even? Does anybody in here know or remember what it means to be even? Split it in half in the middle on the symmetry on the y-axis. So a function is even if it is symmetric about the y-axis. What functions are symmetric about the y-axis? Quadratic. What else? Not cubic. absolute value. And then anything that has an even, no, that's not what I meant. Anything that has an even exponent that's by itself, so like x to the 4th, x to the 6th, x to the 8th, dot, dot, dot. Okay? Now one of my trig functions is even. What it means to be even is that it does not matter if you have a positive or a negative x. Do you agree they have the same y? That's what it means to be even. F of x is the same thing as f of negative x. Cosine of theta and secant of theta are both even. Do you agree that cosine is negative in the second quadrant? Right? But do you agree even though it's negative in the second quadrant, it still has the same y value? Regardless of, right? So that's why it's even. It's symmetric about the y-axis. Okay? And because cosine is, secant is as well. Okay? What about odd? A function is odd if, does anybody remember? A function is odd if it is symmetric about the origin. Meaning if I rotate it 180 degrees, it will be the same picture. For instance, I'm going to draw a line. Y equals x. Do you agree if I turn my paper 180 degrees around? Isn't that the exact same picture I just had? It's odd. So examples of that are y equals x, lines that go through the origin. What else? Cubic. X cubed, x to the 5th, x to the 7th. Anything odd that's just the exponent is odd. As well as your other trig functions. Sine and cosecant. And tangent and cotangent. Now, where these are the same, whether x is positive or negative, do y'all agree they're equal?
Yeah.
That's not the case for odd. Odd has a negative out front. I'm sorry, this should have a negative inside of it. What we just wrote down might not make a lot of sense, but I'm going to show you how to apply it to trig now. It's hard to do this when we're not doing the graphing. We're doing that next unit. I'm running out of room, so I'm going to go to the next page. Can I flip this over yet? Are y'all good with these notes? Okay. So we're going to do, I think, let's see how many examples. We'll do 5 examples. The sine of negative 45. Yesterday we learned how to do this. What did I tell you to do? Add 360. You can still do that. Or you can apply the even odd property. Is this sine even or odd? Odd. If it's odd, what happens to my negative? It goes out front. If it's odd, the negative goes out front. What is the sine of 45? And then what do I need to do with this negative? Put it out front, and that is my answer. Some of you are going to be like, nah, I'd rather add 360. I don't want to remember that. Some of you are going to be like, that was cake. Let me do that. It's up to you. Okay. What questions can I answer? What about the cosine of negative 270 degrees? That is even. Well, what happens with an even function? It's the same. The negative goes away, because do you agree they have the same y's? So this is equivalent to the cosine of 270. With even, your negative goes away. What's the cosine of 270? Does that make sense? What about the cosine of negative pi? Cosine even or odd? Even. So because it is even, what's going to happen? The negative disappears and it just becomes cosine of, or it doesn't disappear, they're just equivalent. What is the cosine of pi? And that's my answer. Even, they're equivalent, the negative goes away. Odd, you bring the negative out front. What about the tangent of negative 5 pi over 4? I hear y'all saying odd, tangent is odd. So what's going to happen here? Negative goes out front, and it becomes the tangent, negative tangent of 5 pi over 4. What is the tangent of 5 pi over 4? Well, hold on. What's the tangent of 5 pi over 4? 1, because it's in the third quadrant. And then I got to bring my negative out front, so what's my answer here? Negative 1. Is this making sense? Again, on Tuesday's quiz, you can do this, or couldn't you add 8 pi? Either way works. Whatever you prefer, which method you're more comfortable with. If I were you, I'd maybe start some of the homework so you're ready for that quiz. The even odd ones start on 76, but the homework's not due till Wednesday. All right, last one is the secant of negative 2 pi over 3. What is the secant of negative 2 pi over 3? Even or odd? Even. So because it's even, what happens? Oh, the negative goes away, so it's just going to be the secant of 2 pi over 3. Do you know the secant of 2 pi over 3 at the top of your head? No, I don't. But what do I know?
The cosine.
I know that cosine is the reciprocal. And what is the cosine of 2 pi over 3? Negative 1/2. And what's the reciprocal of negative 1/2? What is Miss Nelson doing up there? And that is even and odd. Do I have any questions? Okay, we have like 10 minutes left in class. I just want to do one problem real quick that you're going to see. And this is just a simplifying problem. Can you simplify the sine of 30 minus the cosine of 45 degrees? Can you simplify the sine of 30 minus the cosine of 45 degrees? What's the sine of 30? Minus, what is the cosine of 45? If you leave it like this, I will count points off. I want one number. That one number just means I need to find a common denominator. If you tell me that is negative root 2, that is wrong. Do you agree these have a common denominator already?
Yeah.
What is that common denominator? 2. What's going to go on top? Literally this. That's my answer. That is one whole number. Okay? A lot of people, what y'all do is y'all see this and you're like, oh, that's negative root 2, and you just kind of ignore this. Or you like try to multiply. I don't know what y'all try to do. I don't, like if I did that, I don't even know. But just be careful. You are just going to do that. Do y'all want to see another, or are y'all okay?
I'm okay.
Okay, I heard one person say another. If you're okay, you don't got to write this down. If you want to see another, what about the sine of 45 plus the cosine of pi? Ooh, this is a good one. This is a harder one. What's the sine of 45? Root 2 over 2. What's the cosine of pi? Negative 1. What is this going to equal? It is not negative square root of 2.
1 minus 2.
What did you say?
1 minus 2.
No. It is going to be the root of 2 minus 2 over, and you cannot simplify that.
Oh wait, what if it's square root of 2? I mean, minus 2 plus square root of 2 over 2.
Negative 2 plus the square root of 2 over 2 is correct. Does everybody see why this is 1 becomes 2 over 2? And then they have the common denominator. Don't try to eliminate, don't try to do anything else. A lot of people put this as a 1. Y'all forget it needs to be 2 over 2. And then y'all also do, I don't know what. Y'all try to eliminate, oh, these all reduce. They don't all reduce. Can't do that either. Just leave it like that. Okay? I am done teaching for today.